Video we look at this MIT integration P question. This appeared in the final of 2022. So we can start off by expanding the integrand. So I'm just going to expand this integrand here, and then I will come back later on for the integral. But before we proceed with the video, we have to know this. That is the sum of a and b and c squared. This one can be written as a squared plus b squared plus c squared plus 2 times the cross terms, that is ab plus ac plus bc, like this. So this one can be likened to a plus b plus c squared, and this one the same as the cosine terms. So let's do that right now. So we can expand this one. So the first one is going to be the sine squared of 20x plus the square of this. Square of that is going to be 9 sine squared of 21x plus the next one is going to be the sine squared of 22x. That is the sum of these guys, sum of squares of those, plus 2 times the cross terms. So the cross terms, the first one is going to be this times that. That is going to be 3 times the sine of 20x, the sine of 21x, plus this times this, that is going to be what? Sine of 20x multiplied by sine of 22x, plus this times that, and that is going to give you 3 sine of 21x, sine of 22x. So we are done with the sine terms. We have to move on to the cosine terms. I'm going to do that in a different color. So the cosine terms, the first one is going to be the cosine squared of 20x plus 9 times the cosine squared of 21x plus the cosine squared of 22x. So I'm done with the square terms. I'm now going to the cross terms, plus 2 times the cross terms, this guy times this guy. So that is going to be the cosine of 20x multiplied by, that is 3 times the cosine of 20x and the cosine of 21x. Plus this times that, and that is going to be the cosine of 20x multiplied by the cosine of 22x. And the last one is 3 times the cosine of 21x and the cosine of 22x. So this is the expansion of our integrand. And now we have to know the famous identity. The famous identity, that is the Pythagorean theorem, where the sine square of x plus the cosine square of x is going to be equal to 1. So this implies that if you are summing these guys, so sine square of 20x and then the cosine square of 20x, these guys, when you sum them, they will sum to 1. I'm just going to write that here, plus 9 sine square 21x and then 9 cosine square 21x. When you sum these guys are going to sum to 9. Factorize 9 out, you have sine square 21x plus cosine square 21x, and that is going to give you 9 times 1, which is 9, plus sine square of 22x is going to sum to 1 with cosine square of 22x. So we have 1 plus 9 plus 1 for these 6 terms. And now we have the cross terms, right? So we have to multiply the cross terms out. Plus 2 times this, that's going to be 6 sine of 20x, sine of 21x, plus 2 sine of 20x, sine of 22x, plus 2 times 3 here, that is going to be plus 6 sine of 21x, sine of 22x, like this. So, and then we have the cosine terms as well. So the cosine terms, that is going to be 2 times this guy, that is going to be plus 6 cosine of 20x, cosine of 21x, plus 2 times this, that is going to be plus 2 cosine of 20x, cosine of 22x, plus 2 times this, that is going to be plus 6 cosine of 21x, cosine of 22x. So this is our expansion. So this one, 1 plus 9 plus 1, that gives you 11. And then I'm just going to group these terms. So this term and this term can be grouped together because they have 20x and 21x. So they have 6 in common, can factorize 6 out, and that is going to be sine of 20x plus sine of 20x, sine of 21x, then plus cosine of 20x, cosine of 21x. That is for this guy and this guy. And then these ones are also having 20x and 22x in common, and they have 2 in common. You can factorize that one out. You have sine of 20x, sine of 22x, plus cosine of 20x, and then cosine of 22x, like this. And the last one, 21x and 22x. You can group that one, and they have 6 in common. Factorize that one out. We have sine of 21x, sine of 22x, and then plus cosine of 21x, cosine of 22x, like this. Cool result. And now here we are going to compare this one to the double angle identity of cosine. If you have cosine of a minus b, this one is the same as cosine of a, cosine of b, plus sine of a, and then sine of b. So these ones can be likened to cosine of a minus b, right? These ones, right? So because you have sine of 20x, sine of 21x, and plus cosine of 20x, cosine of 21x. So those guys can be written as the cosine of one variable minus another variable. So this is 11 plus 6 into this one here can be written as the cosine of a minus b. So cosine of 21x minus 20x, plus 2 into this one can be written as the cosine of 22x minus 20x, plus 6 times this guy can be written as the cosine of 22x minus 21x, like this. So this is 11 plus 6 cosine of 21x minus 20x is just x, plus 2 into cosine of 22x minus 20x is going to be 2x, plus 6 times 22x minus 21x is x. So that is 6 cosine of x, like this. And we have to know another identity, right? A lot of identities here that we have to know. So we know that the cosine of 2x can be written as 2 cosine square of x minus 1. So we can just replace that here. So our integrand, this is now 11 plus 6 cosine of x plus 2 into cosine of 2x, which can be written as 2 cosine square of x minus 1 plus 6 cosine of x, like this. So we have 11 plus 6 cosine of x plus 4 cosine square of x minus 2 plus 6 cosine of x. So we can now group this one. So this one is 4 cosine square of x plus 6 cosine of x plus 6 cosine of x plus 11 minus 2 is 9. So let's group these ones together and these ones two together. So the first one, we can factorize something common out. So we can factorize 2 cosine of x out because that is common. What is left here is 2 cosine of x minus and plus. This one is left 3 plus what can be factorized out here is 3. And then what is left here is 2 cosine of x plus 3 here. And then this one can be written as the 2 cosine of x plus 3 out, and then 2 cosine of x plus 3. And that is equal to what? 2 cosine of x plus 3, all this one squared. So our integrand, this one is just 2 cosine of x plus 3 all squared. But you remember it's raised to the power half, is under a square root, so we have to put that under a square root. So our integral is just the integral of our integrand, which we have found down there, raised to the power half. So we can just go down there and then wrap it up. So the integral is now the integral of the integrand, and the integrand is now this, which is 2 cosine of x plus 3 all this one squared, but it is under a square root, that is raised to the power half dx, like this. So I is now going to be the integral. This will cancel that, and you are now integrating 2 cosine of x plus 3 dx. What seemed impossible in the beginning has now been reduced to something that is very easy. So this one is now 2 the integral of the cosine of x dx plus 3 the integral of 1 dx. So just integrating them term by term. So our integral I is going to be 2 integrating cosine of x is sine of x plus 3 integrating 1 in the x world is x plus the constant of integration. So this one is the value of our integral. So majority of the work is just in simplifying the integrand, and the integral can just be solved in one line. So the answer is 2 sine of x plus 3x. So we come back here to our original integral. So this one is 2 sine of x plus 3x plus the constant of integration. So this one is the answer to our integral. So this is how I can solve it. If you know an easier and faster way to solve this, please leave a comment in the comment section and let me know what you think. Anyway, I thank you so much for watching this video. Please give me a thumbs up and subscribe to my channel for more content. I will see you in the next one. Bye bye.